Hello friends, today we will learn about vernier calipers. Vernier calipers is the most important and versatile instrument used in labs and industries. It is used to measure precisely small linear dimensions, for example length, height, internal and external diameters of hollow objects, and most importantly the depth of a hollow cylinder or hollow boxes, etc. It was invented by a French mathematician, Pierre Vernier, in 1631. It has two scales and it is based on the principle of difference between the two scales. Out of the two scales named as main scale and vernier scale, it is the vernier scale which is used to increase the accuracy of linear as well as angular measurement. So it has many variants. For example, in navigation it is used in sextants, in surveying it is used in theodolite, and in labs as such we use the vernier calipers as such, or in traveling microscope, spectrometer, etc. So let us first look for the major parts of a vernier calipers. So the major parts are main scale, which is fixed and it is also known as data scales, and then the vernier scale or the indicating scale. It has two pair of jaws, a depth measuring probe, and a locking screw. So let us with the help of this vernier calipers, I'll show you all the major parts and the functions of those parts. So as we say that the first major part is the main scale. This main scale, as you can see, it is just like a simple meter scale. On the lower end of it we have graduation in millimeters, and on the upper side in inches. So we can use either the imperial scale or the meter scale. Then we have this another scale which is sliding on the main scale and is known as the vernier scale. So this one is the vernier scale. We can also see some marking on the vernier scale as well. We'll discuss more about these markings later on. Then along with the vernier we have a depth measuring probe. You can see that this depth measuring probe, this one, it moves along with the vernier scale. So a vernier scale and depth measuring probe is one assembly which moves over the main scale. Then we can see two pair of jaws here. So one pair of jaw, this is for the measurement of the external dimensions, that is external diameter, and this pair of jaw is for the internal dimensions, for example internal diameter of a hollow cylinder. Okay, and this probe is used for the measurement of the depth of a hollow cylinder. So, and this is the locking screw. So when we take any measurement, we fix it and then we tighten this screw. So when we tighten this screw, then this vernier scale doesn't move. So there is no variation in the measurement. So if we have to take the external diameter of the cylinder, then we put this between the lower two jaws and then fix this screw, tighten this screw, and then look for the readings. How exactly we will take the reading, I will tell you later on. So this is how we put this thing in between the two jaws for the external diameter. If I have to take the internal diameter, then these two jaws will be used, and then that time we will fix it. I will insert the jaws like this and then I will open it up with the help of this screw, and then we will fix it between these two jaws. So that time the reading will be taken from here, and then that will give you the internal diameter. Then for taking the depth, what we do is we put this the lower end of this probe so that it touches the bottom of the cylinder, and then we move it in such a way that this is at the bottom of the cylinder, this portion is at the bottom of the cylinder, and this is at the rim of the cylinder. So now we'll see that how to take the measurement with the help of a vernier calipers. Like to start with any of the device for any of the measurement, we must look for two things. One thing is that what is the least count of that instrument, that is what is the least value which can be measured with the help of that instrument precisely, or in which we have perfect confidence. Second thing is that what is the zero error of that instrument. These both things has to be measured for each and every instrument. So let us see for the vernier calipers then how we take the least count. The least count of the vernier calipers is defined as 1 main scale division minus 1 vernier scale division. Now, as I told you earlier also, that this main scale is just like a simple scale. So the least count, the one main scale division means 1 millimeter. Okay, so the value of 1 main scale division is 1 millimeter. Now we have to look for the value of 1 vernier scale division. So for that, hope this is clear to you, we can see there are 50 divisions on the vernier scale. 50 divisions on the vernier scale. Okay, it is marked up to 10, and between each we have 5 divisions. So 50 divisions. And second thing, you will note that 50 divisions of vernier, or they are coinciding with 49 divisions of main scale. Look here, 50 divisions of vernier are coinciding with 49 divisions of main scale, and 49 divisions of main scale means 49 millimeter. So it means the value of 50 divisions of vernier scale is 49 millimeter. So value of 1 division is 49 upon 50. So 1 main scale division is 1 millimeter and 1 vernier scale division is 49 upon 50 millimeter. So that gives us 0.02 millimeter. So this is the least count of vernier scale, vernier calipers. We can compare it with the least count of simple scale, which is 1 millimeter. So we can say that we are very precise up to the second place of decimal in millimeters. Okay. So and this is the least count. Now we will look for the zero error. Now to see the zero error, we must keep these two jaws in contact. So the value should show 0. It means the 0 of vernier should match with 0 of main scale. It means that vernier calipers is free from any zero error. So in this case, 0 of the vernier scale matches with the 0 of the main scale. So this time the vernier is said to have no zero error. So there is no need of any zero correction. Sometimes it happens with wear and tear that 0 of main scale and 0 of vernier scale do not coincide, and that time we say that it is having some zero error. Now what type of zero error and how much is that zero error, we will see. If the 0 of the main scale is on the left side of the 0 of the vernier scale, then the error is said to be positive zero error. In that case, we say that our instrument is measuring more than the actual reading. So that is known as positive zero error. Now if 0 of the main scale is on the right side of 0 of the vernier scale, that time the vernier is said to have negative zero error. It means it will measure somewhat lesser than the actual reading. So we have to account for that. Now how to take out, means this is about the what it is having positive zero error or negative zero error or no zero error. But if there is zero error, how much is the zero error, that we have to see. So to calculate that, let us first see for positive zero error. We have to see that which of the Vernier scale division is in perfect agreement or in coincidence with the any of the main scale division. So we will start from this side and then we'll see that this third division is in perfect coincidence or it is matching with the main scale division. So our reading would be 3. 3 is the Vernier scale division, and then we will multiply it with the least count to get the zero error. So zero error in this particular case is, zero error is the Vernier scale division into least count. Vernier scale division is 3. 3 into 0.02 millimeter, that gives you 0.06 millimeter, and then we will put this positive sign because our zero error is positive in nature. Okay. Then for the second case, here it is having negative zero error. Again we will see that which division of Vernier is in match with the main scale. So here we can see that the 8th division is matching with the main scale division. So the Vernier scale division would be 8. The reading would be 8 and the zero error would be Vernier scale division into least count, that is 8 into least count 0.02 millimeter. So that gives us 0.16 millimeter with negative sign because zero error is of negative type. Now let us see that how to take readings with the help of Vernier calipers. So to start with, we fix that object between the jaws firmly but softly. Then after that we tighten the screw and take the reading. So we have to, first we will see that what is the main scale reading and then what is the Vernier scale reading, because the observed reading is equal to main scale reading plus Vernier scale division into least count. So at this moment it is very clear that our Vernier scale has crossed the 40 divisions of the main scale. Okay, so it has crossed, it is not neither at 40 nor at 41, but it has crossed the 40 division. It means our reading is more than 40 millimeters. So our main scale reading would be 40 millimeters. Now we will see that which of the Vernier scale division is in perfect coincidence with the main scale division. As it can be seen here, that the mark which is denoted by 5 is in perfect agreement with the main scale division. So it means that it is the 25th division on the Vernier scale which is coinciding. So our Vernier scale division would be 25. So now let us see that how we will calculate it. So our main scale reading was 40 millimeters plus 25 on Vernier scale division multiplied by the least count 0.02 millimeter. So that gives me 40 plus 0.50 mm. So that is 40.50 mm is the diameter of the cylinder. So this is how we calculate the observed reading. Then as in our case we have seen that it is free from zero error, so there is no need of any zero correction. So our actual reading will be observed reading only. But if our Vernier calipers is suffering from any zero error, then I told you how to calculate the zero error. We will subtract the zero error from the observed reading to get the actual reading. So the actual reading would be observed reading minus zero error, and here the zero error will be kept with proper sign. It means if the zero error is positive, it will be subtracted from the observed reading to get the actual reading. But if the zero error is negative, then this negative will make it positive. So observed reading will be, actual reading would be observed reading plus zero error. So in this case, this way we apply the zero correction to get the actual value. However, we can increase the accuracy by taking the diameter from various directions and then average it out. So this is how we take the measurement with the help of a vernier calipers. That's all. Thank you and have a nice day.